Hello everyone. In the last lecture we have studied differential form of Faraday's law of electromagnetic induction. This is very laws of electromagnetic induction. This is very important. And that we have to, what is the differential form? That is curl of E bar is equals to minus dou B bar by dou T. This is the differential form of Faraday's law of electromagnetic induction. That is important. We have studied. And now in this lecture we are going to study what do you mean by self-inductance. What is the theory of self-inductance? We have studied first here. After the self-inductance, we have considered another important point, that is definition of self-inductance, explanation of self-inductance. After that, a unit and dimension of self-inductance, and what are the different formulas for the self-inductance. This is the target of today's lecture. In the self-inductance, when a current flowing through a circuit changes a magnetic field. Let us consider this is a coil and this is a positive terminal of battery and this is negative terminal of battery. When coil is connected to the battery, at that time we have to change the current flowing through the coil. And when current flowing through the coil changes, what will happen? That magnetic field linked with the coil. Current flowing through the coil changes, magnetic field is linked with the coil. Magnetic field is linked with the coil. It also changes, so it also induces a EMF. It also induces what? EMF. EMF is nothing but what? Electromotive force. It induces EMF in the circuit or coil. This induced EMF opposes the growth and decay of the current. That induced EMF opposes growth and decay of the current, and such a phenomena is called as what? Self-inductance. Understand what we have to say? When the coil is connected to the connected to the battery, at that time current flowing through the coil goes on changing. When the current flowing through the coil is changing, it links the magnetic field in the coil, and magnetic field in the coil induces an EMF in the coil, and that induced EMF opposes growth and decay of the coil, and that is phenomena is called as what? Self-inductance. And for definition, we have to consider what is the definition of self-inductance. First of all, study here. That is a production of induced EMF in a coil. Definition: the production of induced EMF in a coil. This is very important what we have to consider here. The phenomena of production of induced EMF in a coil due to change in current in the same coil. The production of induced EMF in a coil due to change in current in same coil. Production of induced EMF in a coil due to change in current in the same coil. Due to change in current in the same coil is called as self-inductance. Inductance म्हणा किंवा induction म्हणा. Self-inductance. This is the definition of self-inductance. Production of induced EMF in a coil due to change in current in the same coil, that is called as self-inductance. Another type of concept is mutual induction, that can be considered on the next lecture. But this is important here. The production of induced EMF in a coil due to what? Change in current in the same coil. That is called as what? Self-inductance. Let us consider a coil. I be the current flowing through the coil. I be the current flowing through the coil, and magnetic flux induced in the coil is considered as what? We have to say that phi. At any instant, flux link in the coil is considered as at any instant flux link is phi. Magnetic flux link in the coil is considered as what? Phi. I will the current flowing through the coil. At any instant, magnetic flux or magnetic flux link in the coil is denoted by say phi. And now therefore phi is directly proportional to I. How it is? When the current flowing through the coil goes on changing, what will happen? Magnetic flux is linked in the coil that induces EMF in the coil, and so we have to say that phi is directly proportional to I, and therefore phi this is the proportionality constant here we have to consider. Phi is equals to L into I. What is L here? Where L is a coefficient of self-inductance. Coefficient of self-induction. Then we have to consider by Faraday's law of electromagnetic induction. By Faraday's law or Lane's law, what we have to say that E is equals to minus d phi by dt. Therefore, E is equals to, what is the value of phi here? L into I minus d by dt. L into I. Take the L is constant, taken out, minus L into di by dt. Therefore, in magnitude, negative sign is removed. That is E is equals to magnitude of L into di by dt. And finally, L is equals to E upon di by dt. What is SI unit of self-inductance? SI unit, we have to consider first one. E is measured in, EMF is measured in volt, and current is measured in what? Ampere per second. Or this can be considered as magnetic flux is denoted by, phi is denoted by what? Flux. And I is denoted by what? Ampere. That is, flux is measured in Weber per ampere. Or it is also called as what? A Henry. Or Henry. This is the unit of magnetic flux we have. That is Henry. Volt per ampere second, or Weber per ampere, or Henry. These are the different units for a self-inductance. Secondly, we have to consider here what are the dimensions. Dimension of L is equals to, we have first of all we have to write here V is the volt, and then we have to consider the dimension is what? That is L is equals to volt is nothing but right, we have to here L is equals to, E is considered as work upon what we have, charge, W upon Q, divided by ampere per, what we have to say that, second. That is I by T is there. I by T is there, and this can be written as W upon Q is nothing but IT into T divided by I, and here T gets cancelled. So L is equals to, we have to write here L is equals to W divided by I square, and W is nothing but the work, and having dimension is m raised to 1, L raised to 2, T raised to minus 2, and I raised to what we have to say that minus 2. This is the dimension of a self-inductance. L is equals to W upon I square. This is nothing but the dimension and unit of a self-inductance. Very important. It is measured. Generally, we have to say that self-inductance is measured in Henry. Henry is one of the best unit for the self-inductance. For n number of turns, what we have to consider? For n number of turns, we have one more formula. For n number of turns, we have to consider for the self-inductance. That is important condition. For the self-inductance, we have to write that is n is equals to n into d phi. That is, we have to say that n into d phi is equals to L into d phi di, and it gets that dd gets cancelled. Therefore, n phi is equals to what? L into I. And finally, we have to say that L is equals to n into phi divided by I. This is a very important condition for a self-inductance. L is equals to n phi divided by I. L is the inductance and n is a number of turns. Phi is a magnetic flux and I is considered as what? A current flowing through the coil. What is the self-inductance we have considered here? Self-inductance means we have to say that the production of induced EMF in a coil due to change in current in the same coil, that is called as what? Self-inductance. In the self-inductance, we have to consider I be the current flowing through the coil, and at any instant we have to say that magnetic flux is phi. So phi is directly proportional to I. Phi is called as a magnetic flux and I is called as what? A current flowing through the coil. So phi is equals to L into I. L is the coefficient of self-inductance. And at the Faraday's law of electromagnetic induction, we have to say that E is equals to minus d phi by dt, and phi is nothing but L into I. E is equals to minus L into di by dt. The magnitude is E is equals to L into di by dt. L is equals to E divided by di by dt. And SI unit is considered as volt per ampere second or Weber per ampere or Henry. Dimension of self-inductance is considered as what? Simple formula, we have to simplify it. That is, E is potential. Potential nothing but it is denoted by V. V is work done per unit charge. That is W by Q. And di is considered as I. dt is considered as say T. T gets cancelled. Therefore, W upon I square. W is nothing but the work done. I is the current. So dimension of the self-inductance is considered as M1L2 T minus 2 I raised to minus 2. This is the dimension for self-inductance. And finally, L is equals to N phi divided by I. This is the formula for, another formula for self-inductance. Sometimes we have given number of turns and magnetic flux and current. Find the self-inductance by using this formula. Thank you. Write down all the things.